Okay, exercise set 1.3.3, Physics 11, question 8. A stone is thrown vertically upward with a speed of 18 meters per second. How fast is it moving when it reaches a height of 16 meters? At what time is the stone at this height? Why are there two answers to A and B? Interesting. Okay, let's lay this thing out. So we need to pick a direction. So we're throwing it upwards, so let's pick up as positive. We've got a VI here of 18. .0 meters per second. I've got a delta D 16.0 meters. I've got an acceleration. Now gravity's down, so it's negative. How fast is it moving when it reaches the height of 6? So velocity final. That's what we want to know in part A. That's A anyway. So let's figure that out first. So see VF, VI, D and A. I have the velocity squared one. So delta D VF squared minus VI squared all over 2A. And I've got 16 equals, we don't know VF, VI we know is 18 squared, 2 times a negative 9.81. Clean up some of the math. 16 equals VF squared minus, now let's do 18 squared here. Give me a second. 18 squared, 324. And that's all over a negative 19.6. Alright, multiply both sides by 19.6. So I have a negative 313.6 over here is equal to VF squared minus 324. So add 324 to both sides. 10.4. Sorry, I got stuff coming up here. 10.4 equals VF squared. Let's just go over here. I need to take the square root of both sides. So the square root of 10.4 is VF. .22. So it could be plus or minus too. We should keep this in mind. 3.22. You square either one of those, you'll get 10.4 meters per second. Okay, that's my velocity final. Part B. Let's get ourselves a new slate. Actually, let me try this. Move that over there now. And we'll look at part B. Part B, at what time is the stone at this height? Oh, 16 meters. Right, so at what time? So we need to find t. So this is part B. It's a different color. Something a little more brazen here. I like this blue. Okay, so this is part B. So part B, we just go straight to their displacement equation, the one with time in it, which is VIT plus 1/2 ET squared. Okay, and then we plug in what we know, we have 16 meters. Velocity initial is 18. T we don't know, that's what we're solving for. Ooh, this is messy. I just realized that. 1/2 negative 9.81 times t squared. This is, we'd have to go quadratic formula to do this. And we don't want to do that if we don't have to. So can we attack this from a different way? What's another formula we could use? Here. Instead, let's use the VF from part A to find t. And we can say that D is a VI plus VF all over 2 times t. We can use this to find t. So we plug them in. We've got 16 meters equals VI, which was 18, plus VF, which is 3.22, all over 2 times t. So, to get the 2 off the bottom first, that becomes 32 equals, that's 18, 19, 20, 21.22, 1.22 t. So 32 divided by 21.22 that's 1.5. Okay, sorry. 1.5. So 1.50 or 51 really. 51 eraser. 1.51 seconds equals t. Now we have a little issue here. I want to stop for a moment there. Is that our answer in one was plus or minus 3.22. So I did plus 3.22. We better look at the other one as well. So we could also have done 16 meters equals 18 minus 3.22 all over 2 times t. We would have got 32 equals 18 minus 0.22, 14.78 t. So 32 divided by 14.78, 2.17. So 2.17 seconds equals t. So we have two answers, 1.5 seconds and 2.17 seconds. Why are there two answers to A and B? That was part C. So it makes sense to have two answers. So part C says y 2 times. Okay. And if you think about it, right, the stone would actually be at that height twice. If you throw the stone up in the air, and it comes back down, and this is a height of 16 meters, it's actually at 16 meters here at 1.5 seconds, and it's at 16 meters again here at 2.17 seconds. So that's why you would get two different heights.